Behold the diamond, a tiny fragment of eternity. It sparkles with an ancient light, a testament to Earth's hidden power. This is no ordinary stone, it is pure carbon, crystallized, the hardest natural substance known. A wonder born from the planet's core. A treasure sought for millennia, its beauty is simply captivating. Light dances within its facets, creating a fire, a brilliance that has enchanted humankind always. From royal crowns to simple rings, the diamond holds a special place. It speaks of love, of commitment, and of enduring, timeless value, a true miracle of nature. Why is it so cherished? Its rarity plays a crucial part. Formed under conditions so extreme, few crystals ever make the journey. Its strength too is legendary, able to cut any other material, yet it can be shaped by skilled hands into gems of breathtaking allure, a paradox of nature's design. So let us embark on a journey to understand this remarkable gem, from its violent birth deep underground to its final dazzling presentation. We will explore its hidden story, the story of the diamond, a journey through time and pressure, revealing how Earth crafts such beauty, an adventure into radiant light. Our story begins far below, deep within the Earth's mantle, a realm unseen by human eyes, perhaps 100 miles down or more. Here, temperatures are immense, over 1,000 degrees Celsius. Pressure, too, is almost unimaginable, 50,000 times that at sea level, a truly formidable environment in this fiery, crushing incubator. Carbon atoms exist in abundance. Ordinarily, they might form graphite, soft, dark, and familiar in pencils, but here conditions are different. The extreme heat and pressure force these carbon atoms together into a unique rigid structure, a lattice of incredible strength. This transformation is not swift. It takes millions, even billions of years. Slowly, patiently, carbon crystallizes. Atom by atom, the diamond grows, each one a perfect, tiny miracle, locked deep within the planet's heart, waiting for a chance to see the light. These are the birth pangs of a diamond, a gem forged in Earth's hottest fires. Only very specific conditions will do. A narrow window of temperature and pressure. Too hot or not enough pressure, and diamonds will not form, or they might vaporize. The Earth's mantle provides this delicate balance. In certain ancient parts of its structure, these are the diamond stability zones, the secret nurseries for these crystals, where carbon becomes eternal. These precious crystals are born deep. But how do they reach the surface? They can't simply float upwards. They need a powerful, swift elevator. This transport comes in a violent form. Deep-seated volcanic eruptions. Not the slow lava flows we often see, but explosive, rapid ascents. A fiery journey from the depths. Magma, molten rock, from the mantle, begins to rise at incredible speeds, faster than a speeding sports car. It rips through the overlying crust, carrying fragments of the mantle with it, including, if fortune allows, diamonds. This magma cools to form unique rocks, known as kimberlite or lamproite, the primary host for diamonds. These eruptions form pipe-like structures, vertical conduits stretching miles deep. Geologists call them kimberlite pipes, or sometimes lamproite pipes. They are the targets for diamond miners. Ancient volcanoes, long extinct, their carrot-shaped remnants hold the key to finding these buried treasures. Nature's express delivery for gems. The journey must be incredibly fast. If the magma rises too slowly, the diamonds might transform back into common, humble graphite, or they could simply burn away. The intense heat of the magma is a risk. So this rapid, violent eruption is essential for preserving the diamonds, bringing them intact to Earth's surface. Once at or near the surface, these diamonds lie hidden within rock or scattered by ancient erosion. Finding them is a monumental task. It begins with careful exploration. Geologists search for indicator minerals, tiny grains carried up with diamonds like garnets, chromites and ilmenites. These clues hint at kimberlite nearby. Prospectors might pan riverbeds for these telltale indicator minerals, or even for an elusive rough diamond. Weathering and erosion can free diamonds from their kimberlite host rock, transporting them into alluvial deposits. Along rivers, ancient and modern, these are called secondary deposits. Often the first places diamonds were found. Modern exploration uses advanced science. Aerial surveys measure magnetic fields and electromagnetic properties of the ground. Kimberlite pipes have distinct signatures. Soil sampling reveals mineral traces. Careful analysis points the way to potential drill targets for testing. It is a patient scientific treasure hunt, spanning vast and remote territories. Discovering a viable diamond deposit is incredibly rare and very costly. Many kimberlites contain no diamonds or too few to be mined economically. Only a tiny fraction are rich enough to warrant the enormous investment of setting up a full-scale mine. The earth guards its treasures closely, yielding them only after great effort. When a rich deposit is confirmed, the immense work of mining begins. There are several methods to extract diamonds, depending on the deposit's nature. Open-pit mining is common for kimberlite pipes. Huge terraced pits are excavated, digging deeper and deeper into the earth to reach the diamond-bearing ore. It's honestly a truly staggering feat of engineering. This involves powerful machinery. Massive drills bore into the hard rock, creating holes for explosives. Controlled blasts then break the ore apart, fragmenting tons of rock at a time. Safety is of course paramount in these operations. Engineers plan each blast carefully to loosen the kimberlite efficiently while protecting the workforce. Giant haul trucks, which are honestly some of the largest vehicles on Earth, then transport the broken ore. Each truck can carry hundreds of tons up steep ramps out of the pit to the processing plant nearby. This is a continuous round-the-clock operation, moving millions of tons of rock, all to recover a relatively small quantity of precious, hidden diamonds. Underground mining is another method used when the kimberlite pipe goes very deep or for alluvial deposits buried underground. Shafts are sunk and tunnels are dug, following the diamond-bearing layers. This method is complex and challenging, requiring sophisticated ventilation and support, but it allows access to deeper treasures, continuing the quest far below the surface. The journey of the diamond is not over. Once the ore is mined, it must be processed. The aim is to separate the diamonds from the vast quantities of host rock. This begins with crushing. Giant crushers reduce large boulders into smaller, more manageable pieces. This is a multi-stage process, gradually breaking down the ore. Next, the crushed ore is washed. Water and scrubbing help to remove lighter materials like clay and soil. The ore is mixed into a slurry, which is a dense mixture of rock and water. This slurry then undergoes further separation based on the density of the materials. Diamonds are relatively dense compared to most of the host rock. Several ingenious methods are used to exploit this density difference. Dense media separation is common. The ore slurry is mixed with a fluid containing fine, heavy particles like ferrosilicon. Heavier minerals, including diamonds, sink, while lighter waste material floats. This concentrates the diamond-rich fraction, greatly reducing the volume to be searched. Other techniques rely on diamonds' unique properties. Grease tables were once widely used. Diamonds are water repellent, but stick to grease. Wet gravel passes over the greasy surface. Diamonds adhere while other minerals wash away. More modern plants use X-ray fluorescence. Diamonds fluoresce under X-rays. Sensors detect this glow, triggering jets of air to blow the diamonds into a separate bin. After initial separation from bulk ore, the concentrated material still contains a mix of diamonds and other heavy minerals. Now the final sorting takes place, often by highly skilled human sorters. Their trained eyes can spot a diamond amidst a pile of similar-looking gravel. It is a painstaking, meticulous process requiring immense concentration and expertise. The rough diamonds recovered vary enormously in size, shape, and quality. Some are tiny, industrial-grade stones. Others are larger, gem-quality crystals. Each rough diamond is carefully examined, and its potential value is assessed. Factors like color, clarity, and carat weight are all considered in their rough state. This initial assessment is crucial. The shape of the rough diamond also plays a significant role. Some are beautifully formed octahedrons, while others are irregular or broken. The sorter looks for internal flaws, cracks, inclusions, or cloudy areas. These will affect the final gem's beauty and how it can be cut and polished. A challenging puzzle for the experts. These experts decide the fate of each stone. Some may be suitable for industry, used in cutting tools or abrasives due to their incredible hardness. The most promising stones, however, are set aside for the skilled lapidary to be transformed into dazzling jewels. This selection process is vital, ensuring only the best become gemstones. The journey from a rough diamond to a sparkling, faceted gem is one of incredible skill and artistry. This is the work of the lapidary. First, the rough stone is carefully planned. The cutter decides how to divide it to maximize yield and beauty. often using computer modeling today to map inclusions and potential cuts. The diamond is then cleaved or sawn. Cleaving follows the diamond's natural grain. A sharp groove is cut, then a tap splits the stone cleanly if done right. Sawing uses a diamond-dusted blade to cut against the grain very slowly. This initial shaping is critical. It determines the basic form from which the facets will emerge. Next comes bruting or girdling. Two diamonds are rubbed together to grind them into a round shape or the outline of the desired cut. This prepares the stone for faceting. Then the painstaking process of polishing begins. The diamond is pressed against a spinning wheel, a cast iron wheel called a scaife, coated with diamond dust and oil. Each tiny facet is precisely ground and polished onto the diamond surface at exact angles and proportions to control how light enters and exits. This creates the gem's brilliance and fire, the sparkle that makes diamonds so prized. It requires immense patience and precision, transforming a dull stone into a radiant masterpiece of light. After the cutting and polishing are complete, the finished diamond undergoes scrutiny. Quality control is exceptionally important. Experts examine each gem meticulously. They assess the famous 4 C's: carat weight, color, clarity, and cut. These factors determine its final value and its breathtaking visual appeal, a testament to its journey. Many diamonds are sent to gemological laboratories. Independent organizations provide certification, such as the Gemological Institute of America or the International Gemological Institute. These labs issue detailed grading reports describing the diamond's characteristics. This provides an unbiased assessment and assures the buyer of its quality, a seal of authenticity for each gem. This certification is a crucial step. It builds trust and transparency in the diamond marketplace worldwide. The report details measurements, proportions, and any treatments the diamond may have undergone. It is like a fingerprint for the stone. Unique and verifiable documentation protecting both buyer and seller, ensuring fair trade and confidence. And so our journey concludes. From deep Earth's fiery pressure cooker, through explosive volcanic journeys, past colossal mining operations and the intricate dance of separation, to the skilled hands of the cutter, the diamond emerges, a symbol of endurance, rarity, and pure beauty. A tiny piece of starlight held in our hands, forever admired, forever precious.